Hi, it's Reda here. Usually I do a lot of videos talking about training, fitness, nutrition, but today is slightly different. There is something maybe you don't know about me. I have masters in maths, and I'm gonna launch videos helping A-level students in maths physically and mentally, and try to help them to get successful and positive results in their exams. For today's topic, I'm gonna talk about proof, which is really important. Proof. But as you know, in maths, proof is the main thing. Basically, being given an equation or problem and ask you to prove it if it's true or false, if it's correct or incorrect, whatever you've been asking and been told to prove. But for today's what we're going to talk about proof of induction. Proof by induction. Proof by induction is the most common proof in math, and it's really important, and sometimes it's a bit confusing. But today I'm gonna make it easy and simple, and how to use it for your equation when you've been asking to use it to prove any statement if it's true or false. Let's say there is 4 steps to prove any problem if it's with proof of induction. The first step is, obviously you're going to be given in your problem or exercise, it's like something to prove that is true. First thing, there's 4 steps first: 1, 2, 3, and then 4. The first step, what you have to do at first is showing that the statement you've been given in your exercise, the statement is true. If you've been told to, if you've been asked to prove that it's false, you have to prove that it's false. But what you have to do, let's say you've been told or asked to prove that it's true, what you have to do, show that the statement is true first. You have to show it true for what? For an initial value, basically the base case. Let's say you've got for any number n, and that n is, let's say, equal 1, or n is superior or equal 1. That means you have to prove your statement is true for an initial value n equal at 1. You put that number 1 in your equation or in your function, and you prove that the statement is true. What we call it the base case, basically. Or usually it's n equal 1, or sometimes you've been asked to prove for any value n equal 0, or n superior and equal 0. It's basically starts by n equals 0, but usually 99% of exercise you're gonna be asked to prove for n equal 1 as the first step, the base case. Second, which is that easy and simple, basically just replace any value n by 1 or 0, depends. Second statement straight away. Second step, which is that simple as well, assume that the statement being given in your exercise exactly as it is true. You don't have to change anything. Assume that what been asked to prove is true. That's all. And you have to write it this way, which I'm going to explain in the next video by doing some applications. Assume the statements being given to you is true, and you have to write it as it is, and you said is true for some value n equal a q. Basically n equal at this value here doesn't really matter. You have to name it whatever. N equal a, n equal b, but in general we use these symbols in here. And basically, let's say n equal x. That's it. Let's assume the equation you've been given is true. Just assuming to start with, you have to assume, and you have to write it down to prove that you keep carry on proving that the equation being given on the problem, the function is true. That means n equal x. And then what you have to do is that simple. Step 1, step 2 is straightforward. Step 3, this one, the work has to come on. This is what you have to do, the proper work, which is number 3, using the statement or assumption 2, this, which is you assume that what you've been asked for is true, using this equation in here, which is assumption. In step 2 is true. You have to prove it for the step after this. It's slightly bit here, it looks slightly bit weird. What I mean with that, it's like if you're being asked to prove that for n is true, it's exactly being given in your exercise is true, you assume that it's true, but you have to prove that the step after that, which is q plus 1, n equal q plus 1, or n equal x plus 1. Here we said excuse me, here we said n equal x, and here we're going to say n equal x plus 1. What you have to do in here, you take the equation or the function as it is, you place or you replace every single n or x by x plus 1. That's all you have to do, and you break it down slowly, and you go slow, which is I'm going to explain our exercise in the next video, until you manage to prove it that is true. Let's say is odd number or anything you've been asked for to do, you have just to prove it for this equation here. All you have to do in here to make it simple, and to be honest with you, there is nothing really difficult. You just have to break it down slowly and focus on the numbers. You have to break it down slow, step by step, until you come back to your initial statement, which is in here in number 2. And then in number 4 in here, all you have to do, basically you have to write every single thing in here. It's like a little paragraph, but you have to write it in here in number 4. It's basically, you said, write everything in number 4, which I'm going to explain for what is that easy when we do some applications. Basically, what is it? Proof of induction. Just to recap, proof of induction is basically you have to prove that the function or the problem you've been given exercise is true. Let's say true or false. Here, let's say true. To prove it that it's true, what we have to do, go back to the basics first, which is the basics you're going to be given again in your exercise. You don't have to, like, let's say, create it by yourself or squeeze your brain. Everything is going to be given in your exercise. Let's say n superior or equal 1, superior or equal 0, depends, but usually it's going to be n equal 1. It's basically n superior or equal 1, then you can start superior and superior equal 1. What that means, n is superior of 1 or n equals 1. It's you start from here, n equal 1 or n equals 0, and you replace the n, any number in your function, by number 1, and you prove it that it's correct, which is that simple and easy. Second step, which is assume the exercise the question been asked for is true. That's it. And then you have to prove it for the next step, which is n equal x is true. Then we have to prove n equal x plus 1. It's like it's the next step is true as well, and you prove it by just break it down numbers and symbols step by step. Is that easy? You don't have to worry about it. And then in fourth step, you have just to write everything down in a little paragraph, which is going to show you the keywords to write it in your exam paper. Then it's going to be that easy and understandable for your teacher to put you, so I'd like to give you the whole mark, and you're going to be successful in your exercise. It's basically proof on assumption in here. You can move that. Be careful with that, unless you have to prove the first step. If you don't prove this one in here, you can't move ahead. Quick example of this: if I give you a ladder, we got a ladder here, and I'll ask you, prove me in maths, obviously, and I'm gonna ask you, prove me this ladder it's like we can use it, or I can trust it, or it's solid, or whatever. I can use this ladder. What you have to do, basically, to climb up this ladder, I have to go from the first rung in here and go up and up and up and up and up. What you have to say, you have to prove me that the first rung in here is solid, and I can count on it, I can use it, I can step on it and move on. If you manage to prove this, that means you can move ahead. If you can't prove this in maths, in this type of proof of induction, we can't move ahead. Then, after proving this is correct, what you have to do, I'm gonna ask you now, prove then this ladder, not just this, 1 million types of this ladder, we can use it. 1 million times. What you have to do, you can't just go like wrong by wrong. What we have to say, for n number of rungs in here, in this ladder, and the next one, the next one, next one, millions ones, we have to prove, we assume that they're all good. But what we have to do, in a number, instead of n, we call x, we're gonna say x plus 1. I have to prove this is good. Once I prove it, it works fine. That means the whole theory, everything I've been asked for to prove, is correct and is true. This is what we call the proof of induction. For today's video, I just explained the proof of induction, what is it about in general, which is simple and easy. There are lots of types of proofs, but this is the one we use a lot in maths, and to prove a lot of what we call a lot of problems, a lot of function. And then in the next video, I'm going to do a couple of applications, basically 2 or 3 examples of applications you might find maybe in your exams, or it's going to be helpful for you, and you can use it properly to understand this all proof of induction. In the meantime, After watching this video, if you need any help or you got any questions regarding A-level maths, please let me know. Drop me a comment or ask me a question. I'm happy to help you, and I wish you all the best, and I'll see you in the next video. Speak soon.